Good morning, good evening, class. So today, so today, I'm going to talk about stress and strain. And before, we need to identify our objective as a student by the end of the lesson. What will you have been achieved? So by the end of the lesson, I'm expecting you to define the term used in properties of materials, then calculate stress and strain formula, then state Hooke's law, finally describe the stress and strain relationship. Okay? Okay. So we'll start by properties properties of properties of materials. So properties of materials, what do you understand? We have sorry, we have strength, elasticity, plasticity, and ductility. So we start by the strength. Strength is the mechanical property that enables a material to resist deformation. Strength. It's usually the stronger the material, the greater load it can withstand. And then the next property is elasticity. Elasticity is the ability of an object or material to resume a normal shape after being stretched. Like a rubber band, when you stretch, it has ability to retain its original shape. Then plasticity, both plasticity, this is the ability to undergo some permanent deformation without rupture. So plastic deformation will take place only after the elastic range has been exceeded. What about ductility? Ductility, this is where is the property of material which enable it to be drawn out into thin wire. So like aluminium, copper, etc. Our next thing we look about is stress and strain. Before you calculate stress and strain, you must understand the chart that I'm showing you about stress and strain. So we'll define a stress as the force applied to a material divided by the material cross-section area. So stress is equals to force over area. Are we clear? And then and then strain is a deformation of or displacement of a material that results from its applied stress. So next slide will show you the formula of stress. So stress is force applied to a material divided by the material's cross-sectional area. So we find that stress, this is the symbol of stress, is equals to force over area. So the SI unit for stress is Newton per meter squared. The for force is Newton, and then for area, is meters squared or centimeters squared. For strain is equals to change in length minus original length over the original length. That is strain. Okay. Now our next thing we look about is Hooke's law. So Hooke's law is stating that the strain in a solid is proportional to the applied stress within the elastic limit of a solid. Okay. So the following drawing will is shown here to demonstrate more about Hooke's law, right? And then our last and main objective will be relationship between stress and strain. The following video will demonstrate the relationship between stress and strain. Okay. So wait a bit. I think I have a problem with this video, but then let's just look for the summary. The summary: in engineering and material science, a stress-strain curve for material given the relationship between stress and strain. It is obtained by gradually applying load to a test coupon and measure the deformation, from which the stress and strain can be determined by tensile testing. The curve revealed many of the properties of material, such as Young modulus, the yield strength, and ultimate strength. Ultimate strength. So I hope you enjoyed this lesson. This will be the end of my session. Thank you guys. Have a lovely evening.